Welcome to lesson 5.5, the area of sectors and arc length. We're going to be building upon what we did last lesson, where we found out how to find the area of circles and the circumference. Now we're just going to find parts of the area and parts of the circumference. It's that simple, so let's go into it. So, what is the area of a sector? What does this even mean, the area of a sector? Well, if you look at this, this is what a sector is, what you see right here. And a sector is just a portion of the total area of a circle. So you have your total area. The sector is just this part of it right here. This would be called a sector. All right? So instead of finding the whole area right now, we're just going to find this area right here, of this portion of it. Now there's a formula to find the area of a sector, and we have it right here. This is the formula written out. And I'll read it out to you, and there's some things that we have to talk about. So to find the area of a sector, what you do is you take whatever this symbol means and you divide it by 360. And what is this thing right here? Well, what that means, you'll see this symbol right here. That is the angle measure of the sector. All right? So what you do is you take the angle measure of the sector, divide that by 360, and you multiply that by the area formula, which is pi r squared. Now, just to talk about this for 2 seconds, this formula actually makes a lot of sense. What you're doing is you're taking the angle measure, right, the portion of the angle to 360, so 60 out of 360, that's the portion out of the total degrees, and you're taking that portion and you're multiplying it by the total area. So this portion times the area. So if it's 60 degrees, it's the portion of 60 out of 360, all right, that proportion times the total area. All right, it's exactly what we just did before. We did this in the last lesson. Now we're just multiplying it by this proportion of the angle over 360. So to find out the area of this sector right here, all we have to do is plug in the angle measure of our sector, which is 60 degrees, and then we're going to multiply that by the area formula, which is pi times r, which is 8 squared. Okay? Well, what we do is we take this and we're just going to plug it into the calculator now. And if you want to follow me, let's plug that into our calculator. So let's turn that on. Oh, I'll do it all new for you. So you should put in parentheses 60 divided by 360. All right? Close your percent parentheses and then multiply that by pi, which you might remember is second, this little upper r squared, and our r is 8. Put that in the calculator and we get 33.510. We'll stop that at the hundredth and we'll do 33.51. So this is 33.51. All right, today we're just going to be doing to 2 decimal places. 2 decimal places. And that's also called, we're just going to be rounding to hundredths today. Hundredths. Okay? All right, so just got to plug into your formula, we're good to go. So let's try another one. In the diagram below of circle A, the radius has a length of 6, which is right over here, and the measure of angle A is 75 degrees. All right, find the area of the shaded region. So we're finding the area of a sector right now, so we need our formula. You should always rewrite your formula. So always start by writing your formula. Always start by writing formula. Writing. It's just good habit, formula. This way it stops you from forgetting it and you know exactly what you should do. So the area of a sector is the degrees over 360 times pi r squared, which is the area formula. What we do is we just plug in what we know. So it's 75 degrees over 360 times pi times the radius squared. All right, let's put this into our calculator. So we pull up our calculator. Let's do this one. So this one is parentheses 75 divided by 360 times pi r squared. Put that in and we get 23.56, and we're not going any farther, we're just doing 2 decimal places to 23.56. So we get area is equal to 23.56. That is the area of the sector. All right, this sector right here has an area of 23.56. All right, rocking along. Now this is the challenge problem. All right, we're going to get a little challenging now. Look at how this is different. In the diagram below of circle E, the area of the shaded region, so they're giving us the area of the shaded region, is 8 pi, and the length of the radius is 12. Determine the measure of angle E. So notice how this is different. Now they have given us the area of the shaded sector, and they've given us the radius, and we want to find the angle. Now to solve this problem, what you're going to do is do things a little differently, but once again, we're going to plug in. So we have the area, we have the angle, and we have the radius. What we're going to do is plug in what we know. So we know that the area is actually 8 pi. They tell us the area of the shaded region is 8 pi, so we're just going to plug that in for area. See how that goes in there? They also tell us that the radius is 12, so we're going to put that in there. What we're trying to find is this angle measure. That's the angle E. So let's put an X there because we don't know what it is. All right? So that's a good starting point. Now we're going to keep simplifying this. So what we get is 8 pi is equal to X over 360 times pi, and let's do this. We get 144. All right, 12 squared is 144. So I just squared this to get 144. Now you might remember from last class that if you have a pi on both sides, you can cancel them out. And now we just have 8 is equal to X over 360 times 144. Now I know what you're thinking, like, damn, this looks hard. But whenever you have a fraction, this is your next step, okay? You're going to put a parenthesis around this, and you're going to multiply both sides by 360, because we have this denominator of 360. The way to get that out of there, let's multiply both sides by 360. Let's cancel this out. These 360s cancel out, and 360 times 8, we get 2880 equals X times 144, so let's just call that 144X. Final step, divide both sides by 144. All right, and what we should get, let's put that in the calculator. I'm even taking my calculator out, and we get 2880 divided by 144 is 20. So we found out that the measure of angle E equals 20 degrees. Now by no means was that easy, okay? I understand that. But just to go through the steps again, what we did was we plugged in that our area was 8 pi, and we plugged in our 12. First thing we did was we squared our 12 to get 144. We canceled the pi's on both sides because there's a pi on both sides. And then to get rid of this denominator, we multiplied both sides by 360. When I did that, these 360s canceled out. And then I multiplied 360 by 8 and got my answer. And then I just solved from there. All right, those 3 steps are crucial. All right, for the second part of this lesson, we're going to be doing arc length. And an arc length is just a portion of the total circumference. So this would be an arc right here. Oh, see right here from A to B, that is our arc length. Look at that in all its glory and beauty. All right, so AB would be our arc, and we're trying to find the length of just this part of the whole circumference. All right, so this is just like our last formula. What we're going to do is we're going to take the amount of degrees of our sector, all right, so just that amount of degrees. We're going to divide that by 360, and we're going to multiply that by the circumference formula. So that is the circumference formula. Circumference formula. All right? So it's just the same thing you did, the circumference formula, which is right here. And you multiply that by the amount of degrees over 360. So we're just going to plug in and let's try this out. So L, which is what we're going to call our arc length, we're going to call that arc length with our L, is just going to be the amount of degrees. In this case, it's 30 degrees over 360 times 2 pi times, what's our radius? 10. All right, let's put that into our calculator. So let's clear this out. We get 30 degrees. Oh, let's put our parentheses. So 30 divided by 360 times 2 pi, and then our R is 10 in this case. All right. And if you see here, we get 5.235, and that rounds up to 5.24. All right, so our L is equal to 5.24. All right, so that would be the length of AB, 5.24. Pretty straightforward. Let's try it one more time. All right, circle A has a radius of 18 and the measure of PAQ is 150 degrees. Determine the length of arc PQ. Remember that little thing means peak, arc. So we're just going to plug into our formula. First, we write our formula first. Write formula first. Okay. So now that we've written our formula, let's plug in. So our angle is 150 degrees. All right, and our radius is 18. We're going to just plug this right into our calculator. So let's take out our calculator again. All right, clear this out. Parentheses 150. You should try this on your own, by the way. You don't have to wait for me to do it. Divided by 360 times 2 pi. What was our radius again? I think I forgot that already. Nope, that's not what I wanted. What is going on? That's what I wanted. 2 pi times 18. Thank you very much. 18. Put that in. You get 47.12. We don't round that up, so it's just 47.12. All right, and that is 47.12. Look at that. So we could say that PQ, all right, that arc is equal to 47.12. Beautiful work. We're doing great. Well, I'm doing great. No, we're doing great. It's a team effort. Last problem. This is once again one of those challenging kind of problems. In the diagram below of circle A, the length of arc PQ is 4 pi. So this right here is 4 pi. That's given to us. And the measure of PAQ is 24 degrees. Determine the length of the radius of the circle. So in this case, we want to find the length of the radius. So let's call that radius x. Okay, just like we did last time, first we're going to write down our equation. We're writing our equation, write formula, and then we're going to plug in what we know. So what we know is that the angle measure is 24 degrees. All right. We know that the arc length, which is given to us, is 4 pi. And the radius, which we don't know, is our x. So let's plug that in for r. So we plugged in our radius, we plugged in our angle, and we plugged in the arc length, which was given to us. We're going to do kind of like what we just did in the last one. First, we're going to start off by canceling out the pi's in this case. All right, there's nothing to square, so let's cancel out our pi's. And what we get is 4 is equal to 24 over 360 times 2. Now, if you remember from the, 2x. I'm sorry, geez. Now, if you remember from the last problem, I want to get rid of this pesky 360. So let's get it out by multiplying 360. All right, let's get that out. All right, I don't like denominators. When we multiply both sides by 360, it cancels out on both sides. And what we should get is 1440 is equal to 24 times 2x. All right, those two cancel, then we get that. So let's keep solving this. Well, what we should do now is simplify this by doing 24 times 2, which is 48x. We're going to divide both sides by 48. All right, and let's see what we get. Let's put in our calculators. I got one with me right now. Divided by 48, and we get 30. So the radius of our triangle is equal to 30. Now, once again, I want to emphasize here, what we did is just plugged in what we know. We knew the arc length, we knew the radius, we knew the degrees, we didn't know the radius, so we put an x. We multiplied both sides by 360 to cancel out this denominator, and then we just solved for x, and it was a piece of cake. So that's it for this lesson, guys. Remember, don't punch old people. It's really offensive, or cats, because they're lovely. Good luck!